Okay, let's talk about right triangle applications. If we have a right triangle, first of all, we have a right angle and we have the longest side, which is the hypotenuse. And then if we're sitting at one angle in particular, and let's call this theta, okay, so now I'm looking just at this angle theta, or I'm standing here. This is where I'm standing. Then there's a side opposite me, which is the side that the angle opens up to. And there's also a side right next to me, right here, and that's my adjacent. So from this angle, the hypotenuse is always the hypotenuse. It's the longest side, it's opposite the right angle. But the side opposite the angle opens up, and the side adjacent is the angle that it touches it. So look, for example, let's go from this angle up here. If I was at this angle, which we'll call alpha, then the side opposite, would actually be the adjacent. And the side adjacent would be, so these two would switch as far as adjacent and opposite go. Okay, the hypotenuse, on the other hand, is always the hypotenuse. Okay, so the relationships we have are to define are the sine, the cosine, and the tangent, which we know of, but these are on a right triangle. So sine is going to be the opposite over the hypotenuse. So again, I'm going to take away that. We'll go back to this theta. And the sine of theta is going to be the opposite, which is the length of this side, over the hypotenuse, which is the hypotenuse. It's the length of this side. And that's the ratio for any triangle with that angle. The cosine would be the adjacent, which is right here, divided by the hypotenuse. And then the tangent doesn't even use the hypotenuse. It's the opposite over the adjacent. So the tangent doesn't even use the hypotenuse. Okay, so you'll want to know these. A common mnemonic, maybe you've heard this, is SOHCAHTOA, formed from the first letters sine. There's my so, cosine, there's my ka, and tangent, there's my toa. Okay. All right, so you can look at from either angle. If I'm at alpha, then this side is opposite alpha, but it's adjacent to beta. And this side is adjacent to alpha. All right, so make sure we're clear on what those two words mean, adjacent and opposite to an angle. All right, there are some cofunction identities, which is mostly just for your information. But the cosine is the same as the sine of the angle minus this angle, or sorry, 90 degrees, or pi over 2 minus that angle. So in other words, the cosine of 30 degrees, let me do, cosine of 30 degrees would be the sine of 90 degrees, or pi minus 30, which would be the sine of 60. So those are called cofunction. So that might come up. That's just mostly, it's in this section, and I thought I would in that. But let's not think about that right now as much as how do we find the missing angles and sides of a triangle? Okay, now usually it's with degrees because we're inside a triangle. Okay, so we're going to find the cosine, which would be the adjacent over the hypotenuse. So the adjacent to alpha, first of all, I always identify the hypotenuse. So then if I'm standing here, the adjacent is the one right next to it over the hypotenuse. So I get my 15 over 17. If you divided that out, you would get a freaky decimal. And well, maybe sometimes, in this case, you would. And that's what you'll get on your calculator when you would just do the cosine, sine, or tan. Okay, those are divided out. Okay, the sine is going to be the opposite over the hypotenuse. So again, we're right here. So the opposite is going to be the 8 over the hypotenuse, 17. And the tangent is going to be the opposite over the adjacent. So that's going to be the 8 over the 15. Okay, so to give you an idea how to identify these. All right, so how do we use this to find some unknown sides of this triangle? Well, we want to find A, we want to find B. We know we're here at 30 degrees, and we have our opposite, boom, 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 of 30. Okay, so this is our hypotenuse. So if we did the sine of 30 degrees, that would be equal to the opposite, which is 7, over the hypotenuse, which is b. And then I could look at my, so I'm not going to do all of these on the calculator, but I thought I would do the first one. So I want to share this calculator. Okay, so if I wanted to find the sine of 30 degrees, I go sine, make sure I'm in degrees right here, and I would go 30. Okay, and that is 0.5. That's a nice one. Okay, so I'm going to go back to sharing my what I was working on. Okay, so I know that that's 0.5. So that means that 0.5 is equal to 7 divided by b. Well, if I times both sides by b, times by b, so those cancel, then I times this by b, then I would have 0.5 times b equals 7. So I'm just solving this algebraically now. So I would then divide by 0.5, and I would get b is equal to whatever 7 divided, I'm not going to share the screen to save time, so take 7 divided by 0.5, and it should be 14. So that means that b is 14. And now all I need to do is find a. Well, I know that, what a different color, that if I took the cosine of 30, the cosine of 30 degrees on my triangle is going to be adjacent over hypotenuse. So that's going to be a over 14. So if I times both sides by 14, because those will cancel, then 14 times the cosine of 30 degrees is going to be a. And if I do my calculator and I do 14 times the cosine of 30 degrees, you can do this on your own calculator, you should get 12.124. So A is going to be about 12 point, I'm going to put 12.12. Okay, and then my last check is the hypotenuse must be the longest side. Sure enough, 14 is longer than 12 or 7. Okay. All right, so how we label these triangles are capital letters would be, in this case, the angles, and then the side opposite that angle is A, and the side opposite B is little b. And then in this case, the side opposite the right triangle is little c. Okay, so to solve a triangle means to find each angle and each side length. Okay, so let's say they gave us A was 35. So I'm going to go ahead and draw this. So if 35 degrees was here, and then this is going to be little a, there's my right angle, then that means that little b is 8. That means this is b, and then my right triangle will be c, like the diagram here. Then I'm going to make a box, and I'm going to put my angles on the top, A, B, C, and my sides on the bottom, A, B, C. So I know that A is 35 degrees, and I know that C is 90 degrees, and I know that there's 180 degrees in a triangle. So if I take off my 90 degrees, of course I'm left with 90, and then if I take off my 35 degrees, that leaves me with 55 degrees for B. So I've got my angles, okay? Now I've got one side, little b is 8, and I must find little a and little c. So if I'm looking from 35 degrees, my opposite over my adjacent is a over 8, so I can go tangent of 35 degrees equals a divided by 8. If I times both sides by 8, then I get 8 times the tangent of 35 degrees will give me A. And if I put it in my calculator just like that, I have no round off error till the very end. So 8 tangent of 35, and I'm in the degree mode. Make sure your mode is in degrees. So A equals 5.6. And so then to find C, I could either use the Pythagorean theorem. Let's just, no, we're not going to get to that today. I could use A squared plus B squared equals C squared, or I could just do cosine of 35 degrees equals adjacent over hypotenuse. Adjacent over hypotenuse. I'm going to go ahead and do red, and that will give me my C. So the cosine is 8 over C times both sides by C. So I'm going to have C times the cosine of 35 degrees equals 8. So I'm going to divide by the cosine of 35 degrees. And C will equal whatever 8 divided by the cosine of 35 degrees is, and that on my calculator comes out to 9.766. So I'm going to do about 9.8. Be careful on my open math to how many decimal places your answers go to. And my final check is the longest side is opposite the largest angle. So I'm checking. Yes, my hypotenuse is the longest, and I'm liking that. Okay, let's take a break right now, and we'll go to stop and then continue.